My name is Tegan Brown. I'm a PhD candidate at the University of Melbourne, and I also work for DELWP part-time in the Forest Policy Reform team. Today I'm going to present the concept of my PhD thesis that will investigate the potential for climate change to create forest fire climate feedback loops, leading to nonlinear increases in flammability. Climate change will have important, wide-ranging effects on fire activity across the world, which has the potential to make already fire-prone locations like Victoria even more vulnerable. Fuel moisture content is a particularly important component of flammability because fire activity is so sensitive to small changes in moisture content. The figure on this slide illustrates a central concept to my PhD. Fire frequency is on the y-axis and aridity is represented on the x-axis. Aridity is the ratio of energy to rainfall. Fire frequency in forests with low aridity is controlled by moisture because these forests are usually too wet to burn and they don't get enough energy to dry that moisture out and become available. Fire frequency in forests on the right of this figure with high aridity are controlled by the fuel load. Essentially, can this forest produce enough fuel to sustain high fire frequency? Climate change is going to affect the distribution of energy and rainfall across Victoria, with the potential to move some forests along the x-axis to a higher aridity level. Along the aridity gradient, forest properties that control fuel moisture content, such as canopy density and height, also change, and this can create feedback loops for forest flammability. My thesis is investigating the potential for this to occur. It's critically important that we understand fuel moisture content in a high level of detail. This is because fire activity is extremely sensitive to small changes in fuel moisture content. This figure is from Ellis 2015, and it illustrates the effect of small changes in fuel moisture content on ignition probability, taking ignition probability from 0 to 100 in only a very small band of fuel moisture content. This figure is from MacArthur's 1967 leaflet, again showing large changes in fire properties, this time rate of spread, with small changes in fuel moisture content. The detail in fuel moisture estimates and modelling is important because as land and fire managers, we make decisions based on these data. If we underpredict fuel moisture content, we miss burn windows and we waste resources in preparation for bad fire conditions that don't eventuate. If we overpredict fuel moisture content, when we estimate the landscape is wetter than it really is, this can be dangerous and it leads to misunderstanding the fire danger that is actually present in the landscape. As our climate continues to change, and our forests with it, it's never been so important to understand how both climate and forest properties will drive changes in flammability, and this is what I hope to answer over the next year and a half through to the end of my PhD. Thank you. Please get in touch with me if you have any questions or comments. Thanks.